Download this code from codegive.com, link in the description below. OK, let's dive into the world of flush points, also sometimes called sync points or sequence points, in C and C++. This is a topic that, while sometimes overlooked in introductory programming, is crucial for understanding how compilers and processors optimize code, and how those optimizations can sometimes lead to unexpected or undefined behavior. What are flush points, sequence points? A flush point is a point in the execution of a computer program where all side effects of previous evaluations are guaranteed to be complete, and no side effects of subsequent evaluations have yet taken place. Think of it as a guaranteed moment of synchronization between the code you wrote and the actual changes to memory. Why are flush points important? 1. Ensuring predictable behavior. Compilers are very smart and can rearrange code, optimization, to make it run faster. However, if you write code that relies on the order in which side effects happen, like modifying a variable multiple times in a single expression, the compiler's reordering can lead to unexpected results. Flush points define the safe zones where you know things will be consistent. 2. Avoiding undefined behavior. The C and C++ standards define certain operations as undefined behavior if you modify a variable multiple times without an intervening flush point. Undefined behavior means that anything can happen. Your program might crash, produce incorrect results, or even appear to work correctly sometimes and incorrectly other times. It's a very bad situation to be in because it's hard to debug. 3. Compiler optimization. Compilers use the information about flush points to make informed decisions about how to optimize code. Knowing where side effects are guaranteed to be complete allows them to reorder instructions more aggressively. Key flush points in C and C++. Here are the most important situations where flush points occur. End of a full expression. A full expression is an expression that is not a sub-expression of another expression. This is often the easiest to identify. A full expression is typically terminated by a semicolon. Examples. X equals y plus z. Printf, %d\n, x. Return 0. Logical and, logical or, and comma operator, these operators introduce flush points between the evaluation of their operands. This is crucial for short-circuiting behavior in and. And, the left operand is evaluated first. If it's false, the right operand is not evaluated. If it's true, then the right operand is evaluated. The left operand is evaluated first. If it's true, the right operand is not evaluated. If it's false, then the right operand is evaluated. The left operand is evaluated first, its side effects are completed, then the right operand is evaluated. The value of the comma expression is the value of the right operand. Conditional operator. There's a flush point after the evaluation of the condition and before the evaluation of either the then or else expression. Only one of the then or else branches is evaluated. Function call. There's a flush point just before a function is called, and another flush point just after the function returns. All arguments to the function are evaluated before the call, and their side effects are complete. The return value of the function is available after the call. Return statement. There's a flush point just before a return statement is executed. The return value is computed, and its side effects are completed before control is transferred back to the calling function. Initialization. In C++, and some modern C compilers, there is a flush point after the initialization of each object. This is especially important for constructors. Examples to illustrate flush points and potential problems asterisk. Let's look at some code examples to demonstrate the importance of flush points and how violating the rules can lead to undefined behavior. Example 1, multiple modifications without flush point, undefined behavior. Explanation asterisk. Asterisk in the expression I equals I plus 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 I, the variable I is modified twice without an intervening flush point. Asterisk I plus plus means use the current value of I, 5, in the expression, then increment I dot. Asterisk plus plus I means increment I first, then use the new value of I in the expression. Asterisk the problem is, when do these increments happen, the compiler is free to evaluate them in any order it chooses. Possible outcomes, depending on the compiler and architecture. Asterisk scenario 1 asterisk. 1 I plus plus evaluates to 5, and I is incremented to 6. 2 plus plus I increments I to 7, and evaluates to 7. 3 I equals 5 plus 7, I becomes 12. Asterisk scenario 2 asterisk. 1 plus plus I increments I to 6, and evaluates to 6. 2 I plus plus evaluates to 6, and I is incremented to 7. 3 I equals 6 plus 6, I becomes 12. Asterisk scenario 3 asterisk. 1 The compiler might optimize and do something entirely different. It's undefined. The C and C++ standards explicitly state that this is undefined behavior. Do not write code like this. How to fix it asterisk. Introduce flush points by using separate statements. Explanation of the fix asterisk. Now, we have 3 separate statements, each ending with a semicolon. Each semicolon represents a flush point. The order of operations is now guaranteed. 1 int temp1 equals I plus plus, I is post-incremented, temp1 is assigned the original value of I, 5, I becomes 6. 2 int temp2 equals plus plus I is pre-incremented, I becomes 7, temp2 is assigned the value 7. 3 I equals temp1 plus temp2, I is assigned 5 plus 7 equals 12. Example 2, using comma operator to ensure order. Explanation asterisk. Asterisk the comma operator guarantees that the left operand, x plus plus, is evaluated first, and its side effects, incrementing x, are completed before the right operand, x plus 10, is evaluated. Asterisk x plus plus increments x to 2, and the value of the expression x plus plus is the original value of x, which is 1, but this value is discarded since the comma expression returns the value of the rightmost expression. Asterisk then, x plus 10 is evaluated. Since x is now 2, the result is 12. Asterisk y is assigned the value 12. Example 3, short circuit evaluation with and. Explanation asterisk. Asterisk the and operator introduces a flush point after the evaluation of x equals 1. Asterisk since x equals 1 is false, because x is 0, the right operand, y plus plus, is not evaluated. This is short-circuiting. Asterisk therefore, y remains 0. If we change the example slightly asterisk. Asterisk now, x equals 1 is true. Asterisk the right operand, y plus plus, is evaluated. Asterisk y is incremented to 1. Example 4, conditional operator. Explanation asterisk. Asterisk the condition xy is false, 5 is not greater than 10. Asterisk therefore, the else part, y plus plus, is evaluated. Y is incremented to 11. Asterisk max is assigned the original value of y, 10, before the increment. Example 5, function call and return. Explanation asterisk before increment, x, is called, the value of x, 5, is copied to the number parameter. There's a flush point. Asterisk inside increment, number is incremented to 6. Asterisk the return number, statement has a flush point. The value 6 is returned. Asterisk after increment, x, returns, y is assigned the value 6. There's another flush point. Asterisk the original x in main remains unchanged at 5 because the increment function received a copy of x. Example 6, initialization in C++. Explanation asterisk. In C++, the initialization of objects, particularly with constructors, introduces flush points. In this example, after obj1 is fully constructed, there is a flush point. Then, obj2's constructor is called and its object is fully constructed, which is then followed by a flush point. This ensures that constructors are executed in the order they are written and that their side effects, like initializing member variables and printing to the console, are completed before subsequent code is executed. Best practices and how to avoid problems asterisk. 1. Keep expressions simple asterisk. Avoid writing complex expressions that modify the same variable multiple times. Break them down into smaller, more manageable statements. 2. Use separate statements for increment/decrement asterisk instead of x equals x plus 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 x, right. 3. Be aware of operator precedence and associativity asterisk. Understand how operators are evaluated. Use parentheses to make the order of operations clear. 4. Prefer prefix increment/decrement, plus plus I, when you don't need the original value asterisk. Plus plus I is often slightly more efficient than I plus plus because I plus plus has to save the original value of I before incrementing. If you don't need that original value, use plus plus I. 5. Use a code linter/static analyzer asterisk. Linters and static analysis tools can often detect potential issues related to undefined behavior and flag them for you. Popular choices include ClangTidy, Check, and SonarCube. 6. Compile with warnings enabled asterisk. Use compiler flags to enable warnings. For example, with GCC or Clang, use walwextraupedantic to enable most warnings. These warnings can often catch cases where you might be violating the rules related to flush points. 7. Test thoroughly asterisk. Test your code on different compilers and architectures to see if you encounter any unexpected behavior. In summary asterisk. Flush points, sequence points, are crucial for writing correct and predictable C and C++ code. Understanding where they occur and avoiding multiple modifications of the same variable without intervening flush points is essential to prevent undefined behavior and ensure that your code behaves as you expect, regardless of the compiler or optimization level. By following the best practices outlined above, you can write safer, more robust, and more maintainable code.